Dear participants, in this session we will be going for experiment number 8 of section 2 IAVOC 105. This experiment is related to the electrical technology course that you are studying in your theory coursework, and here we have the object to study the basic characteristics of single phase induction motor. As you can see, we will be performing this experiment with NVIS 7015 single phase induction motor lab. Therefore, we have used the technical manual that they have provided to us to operate this trainer. We will be concentrating on 3 experiments with this trainer. Experiment number 1 will be devoted to the study of a single phase induction motor. In this case, we will be using a capacitor start motor. In experiment 2, we will be studying the running and reversing of the single phase induction motor. And in experiment 3, we will be having the no load test with the motor. There, we will also be determining the power factor. Okay, so remember that you have to be very careful when you are performing any practical with directly high power equipments. This is 230 volt circuit and heavy current will be there in the circuit during its operation. So there should not be any horseplay. And if you are confused at any point or if you do not know the thing, better not to operate. First, learn the things. You should know the theory as well, because without knowing the theory, if you want to just build the circuit, you are only going to damage it or you can hurt yourself. Therefore, be very careful about this thing. Now you can see here, this is the front panel of the induction motor lab. There is an MCB to provide power to the board. This board runs from a single phase supply, our regular supply board. 16 ampere lines should be used. Once you apply power to the board, unless you operate the mains, there will be no operation of the circuit. There are 3 meters. The first one is an ammeter. You can see A1 and A2 are the terminals. Then there is a voltmeter. V1 and V2 are the terminals. Then there is a single phase power meter where you can see the current coil and pressure coil. It has been designated. Now you see here that power output for supply to the circuit is available across these points, the red point and this black point. The black point is neutral and the red point is phase. So once you operate the mains, that means the MCB, this is the 10 ampere MCB, you will be having power across these terminals. Now you see, whenever you come across such lines, direct lines in between two terminals, that means that those terminals are internally connected. Apart from that, there is no internal connection. This particular terminal block is given so that we can have the ammeter in the circuit. This block is given so that we can have the voltmeter in the circuit. This block is given so that we can have the wattmeter in the circuit or the power meter in the circuit. And finally, you have the running winding, you have the starting capacitor, and you have the starting winding. Okay, so this is all about the terminals that are available in the front panel. Now you can see this is the front panel and this is the motor. They are independent parts, and this motor is also having terminals. So let us now look into the breakout of the motor terminals. First, at the outset, you see there are fuses, 10 ampere fuses are there, both for unwinding and start winding. So if the current that is operative on the circuit that goes beyond 10 ampere, the the fuse will be blown so that it remains safe. Now see, this is the terminal, these are the terminals for running winding and these are the terminals for starting winding. Whenever we are to connect the circuit, we have to connect the running winding terminals red to red, and that means line to line, and neutral to neutral, and this starting winding terminals. And then we have the capacitor terminals also. So here we can use the two terminals of the capacitor. Here we can use the two terminals of the capacitor. So this terminal 12 will be connected to this point and terminal 13 will be connected to this point. Terminal 14 will be connected to the starting winding terminal, and terminal 15 will be connected to the starting winding terminal, that is the neutral part. So this is all about the terminals that are available on the front panels of both the control panel and the motor. So now let us look into the specification, technical specification that is required for this trainer and the motor. You can see the motor is capacitor start induction motor. It's a single phase motor. It runs on AC. The voltage rating is 230 volt AC with plus minus 10% tolerance value is there. The RPM is 1440 RPM. The insulation is of class B type, and whatever meters they are used in the circuit is the ammeter. It is of the range of 0 to 10 ampere. The voltmeter is capable to measure up to 300 volt and the wattmeter is capable to measure up to 1500 watts. 1 HP motor is there, that's why the machine rating is given. Definitely all the meters are capable of measuring AC. They are meant for AC measurements. The MCB is of 10 ampere value. Now you see that a detailed safety instruction is given here. Remember that whenever we are to do something with electrical equipment or electrical trainers in the lab or anywhere you want to work with electrical equipment, whenever this 230 volt something or in a three-phase line, you need to be very sure, you need to be very alert, and remember that safety, safety and safety. You must remember this thing. And take my suggestion, never work alone. Never work alone, because we do not know if some accident is there. In spite of all our precautions, there must be somebody to help you out of that danger. Now you see details of the safety things are given, the types of injuries that are possible, the do's and don'ts, they are all given here. And whenever you are working in the DDU KK lab, please remember that phone number or contact number of nearby hospitals are given, so that if there is any problem you can call on the ambulance, or if required the doctor. Before the ambulance or the doctor arrives, what sort of first aid has to be given to the person who is electrocuted, that has also been demonstrated here. And next, remember that be very careful that the lab in which you are working, it has got proper earthing. This earthing is very important, because if suppose the electrocution has happened, then earthing is the only thing that may help you. Therefore, be very sure. Now you will find that detailed theory of single phase induction motor operation has been given. Complete discussion on its internal structure has also been given. Types of single phase induction motor has been given. You can see that this is the motor that we are using, the capacitor start induction motor, and different other types are also given. Operator principle of the motor is given with all necessary diagrams. Therefore, it will be very beneficial for you that once you have completed your theory coursework, and then you go for just a review of the concepts while going through this manual, and that will be very much helpful to you in understanding the operation of the circuit that you are making. Now you see that this is the capacitor start induction and motor. You can find here. You can see this is the main winding and this is the start winding. Single phase supply has been shown, and this is the centrifugal switch, and you can see here this is the capacitor. So whenever the switch is closed, the capacitor is inside the circuit. Now once the motor reaches the speed, the switch is disengaged and the capacitor is removed from the circuit. Then the main winding that actually is capable enough to run the motor. Alright, so the basic speed torque characteristic curve has also been given. I suggest that before starting the practical, you should get into these theories cautiously. So here it is also been given that since this is a 1 HP machine and maximum possible current is 6.5 ampere. Now we will go for the study of single phase induction motor. I will never ask you to initially go for such type of diagram. You kindly try to understand this diagram. You can see this is pretty simple. Once you understand this diagram, even if you look at a very complex terminal representation, there will be no problem for you to build the circuit. You can see here this is obviously a very simple circuit where we can find the line is going to an ammeter so that you can measure the line current when the motor is operating or not operating or operating under various loaded conditions. Then you need to measure the voltage. You can see the ammeter is connected in series, the voltmeter is connected in parallel. Then there is wattmeter. The connections of the wattmeter has been shown here. The upper one is the current coil and the lower one is the pressure coil, so that you can get the value of current and voltage at the same time to make necessary display at the wattmeter. Then there is running winding and there is starting capacitor. Then there is the starting winding. This rotor is simply the illustration of its presence. Now you see here that in the first practical or the first experiment, our primary aim will be to build the circuit so that we can run the motor. Alright, when the motor is running, we will be observing the voltage, current and wattage, that is power. We will also see that if the capacitor is removed, what will happen, whether the motor gets started or not. Although remember, for that particular demonstration, we will have to remove the capacitor for once during starting. But do not wait even for a minute under such a condition. That is dangerous. Alright, because heavy inflow of current will take place. Since the capacitor is not there, that will damage the thing. However, the MCB is there, but do not play that game. This is not actually a game that you are playing, okay? This is a serious experiment. Now again, we will do another sort of thing in which when the motor is running, we will be removing the capacitor and we will try to see whether the motor still operates in such a condition where the capacitor is not there and it is retaining its running state. So remember, these are the basic objectives to start the motor, to see whether without capacitor the motor can be started, to see or to observe. You may note down the voltages and current values and power values when the motor is operating. When we remove the capacitor, try to see what is the difference. Before we start the motor, we remove the capacitor and we try to start it. Let us see whether the motor starts or not. Under that condition, what is the value of voltage, current? You may like to note. In the lab, you have to note it. And in the final case, we will be running the motor and removing the capacitor. And we will see what happens, whether the motor rotates or it stops rotating. So now let us go for the demonstration part. So here you can see the total system. This is the trainer. You can see the values all are at 0. I am yet to start the mains. Even if I start the mains, there is no change in the values because we have not connected the meters in the circuit. And here you can find the motor. This is the brake drum arrangement so that you can put some load onto the motor. That part we will be refraining from this semester experiments, and we will be getting in those aspects with the drives section, which is in your next semester. So let us try to build the circuit first. Remember, while building the circuit, never put on the mains, or it is better to switch off the mains from which the power is coming to the circuit. Okay, so I will use that ethics. I will be putting it off and I will start making the connections. Now remember here that I will be using another uh, camera so that you can have a close observation of how the connections are being made. So let us see here. As I had already told you, these are the two terminals. These two terminals are there. Whenever you put on the mains, these two terminals will be having the single phase supply. From these two terminals, we have to feed the circuit. Alright, so let us start building the circuit. I will try to use the ethics of color coding to the best possible extent. You can see I am from the beginning. Let us start. So this is the first connection we have made. Next I will take that to the next block. The connections are pretty simple, from which I am to take it to the power meter block, and next it goes to the running winding. Then we will have the capacitor in the circuit. I am making the straight connections so that you are not confused. And finally, uh, we will have, maybe I require a shorter connector. We will have this starting winding. Okay, so that is all about the line. Now make all the neutrals common. We will take the neutrals connected here. Then from the voltage block to the wattmeter block, from the wattmeter block to running winding, and from this running winding to the starting winding. So that's all about the basic connection. Your motor will simply work on this. However, you will not be able to measure the voltage or the current or the power. For that, you have to connect the ammeters, voltmeter and the power meter. That we are going to do right now. So I will use this terminal to invite the ammeter into the circuit. So here the first connection is made. Then I will go for the second connection. So here you find your ammeter connected. It is very easy to connect the things, okay, because the mimics are given in such an illustrative manner by the manufacturer that there is no confusion while actually you build the circuit. So you can be rest assured that you can do it very easily. Now let us introduce the voltmeter. So here the voltmeter positive terminal and the voltmeter ground terminal, or sorry, the neutral terminal is connected, and now the power measurement part is there. I will be connecting this W1 terminal, then W2 terminal, so that your current coil is there in the circuit, and finally we will have the neutral connection so that the pressure coil is coming to the circuit. Now we have to take supply or connections from the running winding to the motor. That I will not be able to see because I do not have a camera focused over there. But simply remember, this running winding will be going to the running winding terminal. The neutral will be going to the running winding neutral terminal. The two terminals of capacitor will be going to the two terminals that is there in the motor, and likewise the starting winding will be given to the starting winding terminals at the motor end. So that I will be doing right now. So here you can see I have taken the running winding, and I will give it to the running winding on the motor side. I have taken the starting winding that I will be giving on the motor side, and now I will be connecting the capacitor. Alright, so here I have connected the first terminal of the capacitor and then second terminal of the capacitor. Fine. Now we have to look into the neutral terminals for the windings. We need a bigger wires maybe. Yes, I have got this starting winding neutral terminal I am connecting. Maybe you will be able to see a better. Alright. So here you can see the starting winding neutral terminal that I have connected here. That will be connected to the starting winding. Okay. And finally, the last point, this running winding is connected. Now see, before you charge your circuit, be very careful and check your circuit once again so that you can be rest assured that you can start the circuit without inviting any danger or accident. So now I will change the camera so that we can see that entire operation. So this is the entire view. Initially I will put this view, and after that, in order to have a close look at the values of meters, I will be getting the other camera. So at the outset, let us start the power buttons, and then let us start the mains. So the circuit is now being charged. You can see the motor. Look at the motor. You can find the motor has started rotating. Now let us, under such a condition, let me tell you very clearly that the motor is completely running free. It is not correct, because I have given certain load to it. Certain load, because this is a spring load arrangement. If I rotate this, I will be actually, I am blocking the rotation of the motor. So here I have kept a very slight load onto the motor. The load is to a tune of maybe 0.5 kg. Alright, now see here, I will be getting into the different view. Here you can see that I am simply running the motor. Okay, I am charging it. Now you can find the current is 6.36 ampere, voltage is 237 or 238 volt, near about 240, and the wattage is something around 410 to 420. Okay, so now what I will do, I will put some load onto the motor and let us see what is happening. So initially you can find the current value is 6.35 right now. The power is somewhere around 470. Now I am applying the load. Now as I apply the load, you can see the current requirement of the motor has increased and the power is also going higher. This is very obvious because now the motor has to work against the load. So in order to rotate, it needs more current. I will again put it off. Now our next observation will be to see when the motor is actually running. That means it has started running. Alright. Then if I remove the capacitor terminals, whether the motor rotates or it stops, or there is some change in the characteristic of the rotation. So let us look into that aspect now. So I will charge, your motor starts rotating. Now you see, I will simply remove the capacitor from the circuit. You can see the capacitor terminals have been removed. Still the motor is running. There is no problem in that. Now we will go for a closer observation in the values of voltage, current or power, whether there is any change or not. Alright, I will be again getting the capacitors in the circuit because we need to start the motor with the help of this capacitor. That's it. I will be now going to the closure view. Now you see I am starting the motor with the capacitor present. Okay. Even if you cannot see the motor, you can find the sound of its operation. Now you can see the present value of current is 6.35 ampere, and now I am removing the capacitor. Okay. Now you see here, there is not much change, and still the motor rotates. Okay, and finally we will make another test, but there is a problem with this jumper wire. I will simply remove it and I will use another one because we cannot take a risk, you know. So I use this one. Now we will go for an certain, I should say, dangerous experiment. Remember that whenever you are performing this experiment, you should be this part of the experiment, you should be very careful. Here what we are going to do, here we are going to see whether the motor is started in absence of the capacitor. So we will remove the capacitor from the circuit and we will try to start the motor. So let us go for the first view. Here you can see the capacitor is there. The motor starts. Now I will simply remove the capacitor. You can see I have removed the capacitor. You can see the capacitor has no connection to the motor. Now I will start. You can see the motor will not rotate. But remember, you should do this for instantaneous time. Just charge it, discharge it. Otherwise, your motor will be damaged. So you see here, you can see the motor is trying to start. There is the humming sound is there, but it is unable to start. Now we will get a closure view of the values in the meters. Okay, and let us see how the difference is taking place. Let us change this view and first let us invite the capacitor in the circuit. Let us connect. And now this is normal condition. The capacitor is already present. Please note the current. It's 6.3534 likewise. Okay. Now I will remove the capacitor. You will see that a very high surge of current will be there to the circuit. Now you see here, I have removed the capacitor. Alright. Now kindly note the value of the current in the current meter. You see now the motor will not rotate. Now you can see almost 16 amperes of current was there. I will again start. You can see that high amount of current is flowing to the circuit. So if your capacitor is not there, that high amount of current will flow continuously and your motor will be burnt. Now see that if the centrifugal switch is not working, then what will happen? This heavy amount of current will be continuously getting inflow to the circuit and simply your circuit will be, that means your starter circuit will be burnt. Now I will engage the capacitors in the circuit and again you can see at much a lesser value of current, it is working. You can see here. Now let us go for the second part or the experiment number 2 of the practical. You can find in experiment number 2 we are to study the running and reversing of the motor. So far the circuit is concerned, definitely there will be no change in the circuit, because you have to run the circuit and simply you have to see that how you are reversing the motor. Now the circuit diagram will remain the same. Alright, you can see the connection diagrams also. I always suggest you that just do not go blindly with the connection diagram that is shown here. First understand the circuit. Now remember that in order to rotate the motor in an opposite direction, what we need to do? We need to, you can see here, we need to simply interchange the starting winding connection. You can see white serial number 19. We need to interchange the starting winding connection. Here it is terminal number 14 and 15. So here you can see this is the starting winding connection. We need to simply interchange that. Once we do, we will see that the motor rotates in an opposite direction, that is clockwise and counterclockwise. It will be a bit difficult, you know, to have it to get into the operation, but still I will try. Maybe I will be going for this and I will take it to the motor so that we can have a close view of this is the starting winding, and you can see that is the motor, and you can see whatever we had told, these connections, winding connections are there onto the motor side also. So what is expected here, that in order to change the direction of rotation of the motor, we have to interchange these two terminals, 14 to 15 and 15 to 14. That's it. So first of all we will see here, I will charge the mains, and we can see in this condition the motor is rotating clockwise. So I will make it a bit tougher so that you can see. I will rotate for it. So you can see that's a clockwise direction motion. Okay. So now I will interchange it. So better to put off and simply I will be changing the terminals. All right. So put them on, and now you can see the rotation is counterclockwise. The rotation is now counterclockwise. Okay. Here you can see counterclockwise rotation, and if I change them, you need to be very careful. Problem with this. Okay. Now you see a clockwise motion. It is rotating in this direction, and if I interchange the terminals, it is clockwise and it is rotating. Now it will rotate counterclockwise. This is counterclockwise rotation. So you can see that experiment number 2, that was actually made to see how the direction of rotation can be changed for a single phase induction motor. We have also performed that. You see, I always tell you that performing the experiments just for performing never makes sense unless you understand the theory. Okay, so better you understand the theory well, and you perform the experiments only to see that what you had studied in the theory coursework, whether all those things are true or not. Do not believe anything. See, first see, then believe. Okay, So let us now go for the final part of the experiment, that is the experiment number 3. In this case, we will study no load test of a single phase induction motor. So I will be applying no load. The main purpose of this is to determine power factor. So we have to determine the power factor. So we will be applying no load onto the motor. Then the ammeter reading has to be taken, the voltmeter reading has to be taken, and the wattmeter reading has to be taken. Now if you want a number of readings, then you need a variable transformer to supply the motor. To supply the motor, that I am not going to do here. We will be simply having one reading. I suggest that you note the readings in your notebook and then you go for calculation of the power factor. It is very simple. Whatever reading is there in the wattmeter, that has to be divided with the product of voltmeter reading and ammeter reading. So that is simply the power factor. Now let us get back to our camera view. I will be applying no load to the motor. So I will be making them loose. Alright. And now I will be charging the circuit. So you see. So what you are supposed to do? You are supposed to take this value of wattmeter, take this value of voltmeter, and take the value of ammeter. So I will go for a closer look. Now see, I will charge the circuit. So you can see the current is 6.40 ampere, 239 volts, and wattmeter shows the reading of 334 watts. These are the values. You kindly note them and determine power factor in this case. So that's all for your experiment number 8, that is study of single phase induction motor which is of capacitor type. For any of your queries or questions, kindly put your questions in the comment box. Thank you.